Good evening, everyone. Yeah, as Gavin said, last but not the least presentation, I guess, and thanks for all the mentions about Mapillary as well in the earlier presentations. So my name is Muthu Sampath. I'm a GIS technical sales lead at Mapillary. I'm based in Fort Collins, Colorado. So the company is based in Sweden, but we all work remotely even before the COVID times. So like we have 55 people in 18 different time zones, in eight different time zones in 18 different countries. So today's presentation is mostly about how modern street level asset collection is done using Mapillary with just simple street level imagery and AI based methods. So traditionally, mapping was usually done with vans with expensive equipment and very hard to use softwares and expensive storage methods for storing the imagery. This was not a scalable approach where everyone could afford to do that. And like, especially for instance, like smaller cities or for like smaller projects, this is not a scalable way of doing it. And it's usually outdated as well. Like large companies who do the data collection on a yearly basis, it's not refreshed in every year. So sometimes it's like, for instance, in Fort Collins, the last time Google Maps was updated was like 5 years back or 3 years back. So it's not like a refreshed in a regular manner. So it's always outdated, and maps needs to be updated as frequently as possible, and assets also needs to be updated as well. So your other major problem is the data extraction, the GIS aspect of it. Like it's always time consuming to do it manually, and there are lots of error prone, it's prone to errors as well. So these two, in order to overcome these two aspects, like Mapillary was developed around 2013. So it's a street level imagery platform that scales and automates mapping using computer vision and collaboration with different types of cameras. So we do provide imagery and the data extracted for like community, government, and commercial map providers. When I say community, it's mostly the OpenStreetMap community, who all the data and the imagery is all available for free for them so that they can improve the OpenStreetMap. Like say, if you have a neighborhood which has not been updated at all, you can go ahead and collect imagery and update the maps within the OpenStreetMap, which is pretty much used by many commercial map providers right now. So the methods used are like simple devices, like you can use from like cell phones, action cameras, 360 cameras, dash cams, or even like sensor-based cameras, and the professional rigs, and which can be ingested into our platform. We are pretty much a device agnostic platform, so you can use any device you want for capturing imagery. And then once it's uploaded to Mapillary, it takes up to 24 hours for processing and publishing the data. It can range from like traffic signs, fire hydrants, anything like that. We take up to 24 hours to process and publish the data. So a simple sketch of how the Mapillary platform works. We take an imagery from any device from various types of contributors. It can be community who are doing it just for a hobby, or it can be a government who are looking for asset collection, or it can be a commercial map provider who wants to improve their base maps, or insurance agency who wants to get the fresh imagery of the particular city. So they collect the imagery, and then they provide it on our platform, and we perform a 3D reconstruction and computer vision model to extract the data like traffic signs and any other objects like utility poles, fire hydrants, street lights. And we extract all these objects and merge them as map features and provide it back to the contributor as well. So this all takes up to like 24 hours time frame. Like if it's cell phones, it usually takes like few hours. But if you're using like a professional rig and stuff like that, it takes up to 24 hours for processing. So in order to be compliant with the GDPR policy, which is more stringent than the policies in the US, we do blur all the faces and license plates automatically. So the first thing which happens as soon as you upload the images is like we blur out all the faces and license plates, and then we go for the other object detection and extraction as well. In addition, I usually get this question, how long do we store these images? We usually keep the images up to 6 months. That's the rule as per the GDPR policies. We can keep the original images up to 6 months, and then it's automatically deleted as well from our platform. And we keep only the blurred images on our platform. So after the blurring happens, we do extract all the traffic signs. So we do have like 1,500 traffic signs recognized across 100 countries. all the traffic signs within the US has an additional attribute of the MUTCD code, which is often used by the governments. So that is also an additional attribute which is available along with the traffic sign data. So in addition to the traffic signs, we classify the images for other features as well, ranging from like pedestrians, lane markings, fire hydrants, utility poles, like around 97 classes is being classified along with the traffic sign. So when the processing happens, it usually classifies all the images for all these kind of object detections, and then we extract them as map data within the imagery. So currently we have integrations for multiple map-based platforms. Esri is a common one which is used by the governments and GIS partners. So we have an ArcGIS Pro and the Web App Builder widget integration, which is used very commonly to view the imagery and play with their own GIS data. We also have multiple integrations for OpenStreetMap community who do it on their free time, who wants to improve the OpenStreetMap. So we have integrations with them as well. And we have integrations with our commercial map partners like Here and Mapbox, who update their own base map layers using the imagery license from us. So currently we have like 1.1 billion images in our platform across the world. And this covers almost like 13 million kilometers with around 70 billion objects and 190 countries. So all the images which are available publicly on our platform is completely free to host. We do not charge any hosting on our platform. It has been always free from the start of Mapillary in 2013. So the reason why there is a need for updating the maps and the asset management in general, everyone keeps asking why is there a need for it and stuff like that. So some of the aspects are like, there is always construction happening in like major cities or any part of the world. So there is always going to be like unmapped roads. In this particular instance, this particular road was not mapped at all, even though there is an actual road over there. This was not mapped, and during navigation, by using a ride sharing or if you're having a food delivered, they might not know that there is a street in this particular section. So he might have to go into a longer route for that particular delivery or something like that. So using imagery, we are able to detect these kind of things and provide that within a short span of time. So the other example is the access restriction. So in this particular instance, the map shows that it's a public access way, but it is actually a private road. So these kind of things are not just possible just using satellite imagery. A street level imagery gives an additional aspect of how they can use this information and translate it back into the base map for their consumers as well. So this is another good example of like intersection where the directions was not available properly, but with the fresh imagery, they were able to get in this data and make the maps improved as well. So one of the other component is like the changing aspect of how the roads and neighborhoods change. So with the help of like simple tools we have on our platform, like we are able to change what things have changed, like using imagery. So in this particular example, the imagery is like 2 years old, but you see how much of it has changed within this particular aspect. So it's like a comparison tool we have, which is enabled automatically when it sees multiple images of the same location. So we use a time travel function to see what has changed over time in this particular location. So some of the case studies which how governments and other partners have used, that's what I'm going to show you next. So you can get an idea of how people have used and how you can also use in your different projects as well. So feature extraction, that has been, the traffic sign extraction was the first thing which we released using AI model. So Los Angeles County was one of the first customers for us, where they've been using it using simple GoPro cameras put on their garbage trucks, and they've been collecting imagery all across, and they have like a dense image collection of all the streets for feature extraction. And they have been also using it for like parking study projects internally. And this has been a huge beneficial for them because they can store the imagery and they can collect imagery as often as they want during their free time or just putting the cameras on the garbage trucks. It's based on what the frequency of imagery they would like to have. They could collect imagery and get the data extracted as well. So another use case, this is not a street component, but it does something with the same like imagery collection. So trail mapping, like we often see that the trail maps, there is not much information about trails. Like you might see some trail maps which are a little outdated or there is no much information. So the city, this Westchester County wanted to collect all these information and compare it against the aerial imagery just to see how things can be improved and what additional things can be done as well. So they have been collecting imagery using just cell phones along the trails and using this, uploading to our platform to use it into their internal projects for making into a web-based mapping application as well. So another example is like a TriMet. So since most of our tools and everything is open source and the APIs are all more accessible, we TriMet actually licensed the entire imagery of Portland, which was just collected by gig-based workers using cell phones and Sony cameras. They were able to get the street view imagery for their own projects, and they have an application which is in beta right now for the trip planning. So the consumers and the customers, they can use that app and see where the bus stops are and all this kind of information within the street level environment. So another good example is the Santa Clara, where they've been using mainly for project planning. So they wanted to get the entire street level imagery for the all their roads so that they can see from their office what things can be changed and how to plan for the projects, especially in terms of transit and how the congestions can be improved. So this allows them for not going into the field every time they need to see something or make a quick estimate of something. They were able to do all this within the office space by just collecting the imagery. And whenever they're looking for fresh imagery, they can go out in the field and collect it using Sony cameras rig as well. So another example, which I always like, is the stream mapping. So this one was a nice, like a 360 imagery using like a commercial 360, like less than $500 camera, where they used a kayak and they mapped out all the streams for looking into erosion and vegetation encroachment. And they've been mapping it like once a year or something like that. So they can understand the vegetation encroachment patterns and everything in this particular example. So as a single platform can be used for different purposes. So that's what is done by the government as well. They're looking into roads, but they can also use it for other purposes as well. So a major aspect of our platform is mostly the open data part of it. Like one of the cool things about the Bike Ottawa project is like the citizens wanted to have a more enhanced bike safety, and they wanted to promote this with their government. So mostly the citizens, they use their cell phones in their bikes and collected all the imagery across all the roads. And they've been using the bike detections, using the AI, using that information to see where the bike lanes are good and where the bike lanes have to be improved. And those kind of information are translated back to the city so that they can make measures to improve the roads and bike lanes as well. So another great example is like the city of Detroit. They've been using the Trimble MX2 device for collecting all their information of all the streets. They usually collect on every 3 months. So they have like 5,000 kilometers of roads, and they have a fully paid driver who works for the city, whose only job is to collect imagery and upload it to Mapillary. So as you see, that's a comparison tool. They have been using it for several purposes. One of the examples over here is that they've been using it for property appraisal, where the city assessor just doesn't have to go out in the field. They use just the imagery over here, and they have been also using it for all data extraction and all other needs as well, just within our platform. So this is a common example where Trimble devices have a lot of impact on our platform, like City of Denver, which David mentioned, and even City of Westminster is also planning to do the same project as what City of Denver did, and many other partners like World Bank and All Traffic Data, iWork. They've been all using the Trimble MX7 or Trimble MX9 or MX2 for collection and uploading it to our platform for data extraction and other needs too. So another example is like how we work with DOTs. So the DOTs usually collect the imagery every year as a part of the mandated rule by FHWA, but these imagery is always stored in a hard disk and not used much. So one of the first things when we came across Vermont DOT, they were able to share their imagery onto our platform. So we currently have like 7 years of all their state highway roads on our platform, which was collected by a contractor for them. And they were able to upload that imagery and make it more open to public. And they also have a application which is open to the public where citizens can view the roads imagery and how the roads are and everything in this particular in our platform. This one particular Connecticut DOT, they're also using a contractor for the collection and uploading the imagery to our platform. But in addition to that, they also wanted to do a frequent collection of imagery just by using their own crew and their own collection vans. So they use like simple 360 cameras off the shelf, and they've been collecting imagery, and so they can compare it against their annually collected imagery and see how the roads and everything and maintenance can be done and everything. The one good example was that they have also been using some of the data for autonomous vehicle testing, which they have been using, doing it with a partnership with some autonomous vehicle company too. So this one is a more recent example of the Washington, DC Public Works. So where they've been using our platform for leaf collection project. So this was more interesting for us because they are just interested in the imagery and not much in the data, but they wanted to see how they can be more efficient in telling the citizens that their leaves which are settled in the roads have been removed every day. So this is more of like a resource project. So they wanted to use the images as a main resource for how they can show this to the citizens that all the roads are clean and everything. So they've been used every time they go out in the field, they turn the cameras on, like using the dash cams or even cell phones, and collect the imagery initially, and then again go to the same field to say that, okay, these roads are all clean and everything using the comparison tool which we have. So some of the Mapillary tools which we have right now and is used by many clients as well, like is the spot changes. Like for instance, like there might be a work construction zone or a new sign which is available. These kind of things can be detected automatically through our platform. For instance, like we have the attributes. So for instance, if a traffic sign is detected, we do have that when it was first seen and when it was last seen. So these attributes actually help the end user to say that, okay, after a particular period, the sign is not available. So maybe the sign is down, or there was a disaster or something and the sign is not available anymore or something like that. So these kind of things can be used. AI can help in the automatic changes available within the imagery. And the other instances like where the sign has been changed with the new sign, this all can be detected within the imagery, and they can help in the AI-based detection too. So another thing is like the capture tools. So this one was basically designed to help drivers or even like projects like geospatial contractors who would want to just assign tasks to multiple drivers so that they can collect imagery and then upload it to the platform. So this works both for the cell phone and even for external cameras, where they can just use a cell phone-based app, iOS or Android, and they can assign each Square-based task to any drivers they want. And then in the field, you can collect the imagery, and from your office, you can see where your drivers are, everything in real time. And once the imagery is uploaded, the color turns from yellow to blue, and you can see which all places have the imagery and where you need to collect new imagery and everything. This is more an organized data collection tool where people have used it, and it's completely free. Anyone can use it as well. So another thing is like AI cannot solve 100% of everyone's problems. Many people have that misconception of that. But so in order to overcome that particular hassle, we did develop something called human in the loop process, where we allow the customers or even any partners or organizations, they can train the algorithm for their own particular city or particular project which they have, so that the algorithm learns on its own and improves the detection results later when the new imagery comes in. So this has helped for many purposes, like say in case of bus stop signs. It's very hard for the AI to know the bus stop sign from Fort Collins to a Loveland or Denver and stuff like that. So in those cases, we made sure that, okay, the city or the citizens, they can train the algorithm so that they can help in making the detection better as well. So this is a complete, it's available for all the customers who want to make sure of the technology can help their own city too with the same imagery. So some of the tools which we are looking into is like the custom detections, like logos, or even like billboards. That is something which we are looking into, and even the road conditions. So the road conditions has been done by several companies, so we are still kind of researching whether we have to do it or it's better to go ahead and partner with those companies who do it already. So that is something which we are still discussing with our product team and our engineering team too. So some of the other pilots we have done is like the OCR detection for parking signs. We did a small pilot and it was like 80 to 85% efficient, but this year we will release a production model where anyone can use the same imagery for parking-based detection or OCR text-based recognition. Some of the other pilots we did was like parking and scooter sharing companies for curb detection and sidewalks, and even some of the autonomous vehicle testing for how just cell phone and a dash cam imagery can be used for getting the detections for the vehicles as well. So this is a brief demo of what happens once the imagery is uploaded and everything. So you see all the pixels getting extracted from the imagery, and then we detect all the objects within that imagery. This is a 3D reconstruction point cloud just from the imagery. There's no LiDAR involved in this. It's completely photogrammetric point cloud. So once the data is extracted, then we merge the detections and make it available into the map. So yeah, if you guys have any questions or anything, I'm happy to answer them. No, that's it from me.
This is cool. Thank you, Muthu. So yeah, you've erased my skepticism over the last 2 days. You know, what I thought was not quite possible yet really is. So I want to do, in a line of questions here, I want to throw a hypothetical at you.
Sure.
And with a couple of different assumptions along the way. Okay, so I got a jurisdiction and they really don't have an inventory of, say, the signal boxes.
Mm-hmm.
They need to know where they are and they need to know condition, but they mainly just need to know where they are. Now there's a few standard sizes. They're pretty much half a dozen sizes.
Mm-hmm.
What would you have to teach your system to be able to recognize those?
So generally it gets recognized as a junction box, but if the sizes are different or even the pixels are different, those might not get detected because it was trained before. So in those cases, we might have to train the algorithm again. So later this year, we are trying to make that also available as a product or for which any user can do, where they can train those custom detections. That's what I meant by custom detection. So if anything is custom than what we don't have, we will allow the consumers to train the algorithm for like 10,000 images or something like that, based on the city size and everything like that. And then the next time when you upload the images, it automatically will detect those kind of.
Okay, but that's something that you could do as a service, is to train it. Yep. Now, the data collection, you know, trying to go cheap. We got lots of interns in vehicles, buggies, you know, parking buggies or whatever. Let's say, what's the simplest setup that they could do? Could they set up a smartphone to just grab images periodically?
Yeah, you don't even have to do anything. Once you start the camera with the cell phone, it automatically takes based on the time or distance-based intervals, and it automatically collects images. And once you have Wi-Fi, you can just upload it at the end of the day or something like that. But if your cities are looking for like some simple 360 imagery, we support like some GoPro cameras, which many cities right now use it on our platform, like GoPro Max. It also captures 360 imagery, and it's just $500 or $600, I guess. And it captures 360 imagery with a good resolution, which can be used for data extraction or even visualization purposes. and then you can upload those geotagged imagery as well. And it stitches within the camera. That's a big relief for many city customers because they don't have to stitch externally and then upload and everything. This camera actually stitches everything within the camera, and then you can upload it directly to our platform.
Okay, and then, maybe they decide, well, the idea of, capture once, use many times. Let's go rent a system like the one we heard about in the previous, or the ones yesterday. There's a bunch of systems with those great cameras on them. This one earlier today, the one company makes their own. Any of those is going to be able to provide. Okay.
Yeah.
Okay.
I mean, the basic requirement is like we just need a geotagged imagery. That's all is the basic, and the timestamp. That's all is the requirement for uploading it to our platform. We do not need any other additional metadata for processing the imagery. If you have the location information and the date timestamp, that's all we need for uploading it into our platform.
Okay, and then this cloud that it's creating, they could ask for that as an export.
Not the cloud. We don't sell the cloud as a product.
Okay.
It's just that what happens in the back end. So we don't sell that.
Okay. So, but if they wanted to extract something later, you could train it to do something else. Okay.
Yeah, we can. So all the data can be extracted as a shapefile or any geospatial format for GIS or any other GeoJSON or CSV or anything like that.
Okay, great. Question from the audience. Srihari is asking, this model can be trained or used to detect road intersection access points?
We already have the detections of the intersections in our platform. So whenever we see an intersection, we are able to detect those intersections already. So it can be exported as a object detection file and stuff like that.
Okay, and a question from Fabio about trees, updating trees. Do you have customers that are doing like tree inventories?
So in our platform, we detect trees as vegetation. We do not extract the single point of those trees because it's really hard to train the algorithms for that. So right now, when you see the imagery, if it sees trees, it just saves as vegetation, but we don't extract the single point of feature on that. But still, I've seen customers using it because the city is already using our platform for asset inventory, but they also want to do it for the trees. They just do it manually using the ArcGIS Pro integration and stuff. They are able to do that.
Oh, okay. Yeah. Fabio is asking about updating a trees. So you could to change detection of the vegetation, not inside, but is the tree still there or not? Yeah.
Yep. Like we detect it as a tree, but we won't give you the location of the tree, but just because it's not easy to train the algorithm for.
Okay. A question from Tom is there asset to GIS capability for single features like signs or utility cabinets?
We do detect signs, like all the traffic signs, whichever is available in the US, Europe. That's where all the major imagery is. So that is all trained for. The cabinets, I think for utility poles, we do detect cabinets, but if it's of the standard size and standard pixels, it will detect them. If it is changed in a bit or something, it might not. So that comes in on a case-to-case basis. We need to look into those images. Like if it's a customer who's really looking forward for the entire city or state, we can usually take in those images and then train the algorithm and add it to the database for detection. And then we can upload that imagery and train it for that. So it depends on the demand as well. If it's not of much of a demand, if it's like a one-off basis, then we tell the customer to do it. But if it's like huge demand, like for instance, MUTCD code was huge demand, so we just added it to our database. So whenever the customer downloads the data, they can get all those information.
Okay. What formats do you deliver the output? Can it export to Esri shape or CSV?
Yes, we do it as shapefile, CSV, file geodatabase, and GeoJSON, all the common geospatial formats. Okay,
great. Now I got a question here that I'm not sure about, so I'm going to take a stab at it from the wording. Now I still can't quite figure this one out. I'll try to figure it out. Might ask it during the break. Okay, this is cool. It's kind of on the subject about the open source. Now, I noticed you've got a lot of ties in the open source community. And is it that when you do a project for somebody, that data is by default out there to the public? Or can people require that it is not, or can they say, no, we don't want that public?
So we did have something called private as well, the public and private. So traditionally it is all by default, it's public because no one has to pay for hosting. That is a major cost for
Yeah.
any city or any customer. Whereas when it becomes private, they pay for the hosting and for the data extraction. But recently we actually removed everything private. So we are not supporting private anymore. We want to support the open source and open data community more. So as a company, we decided that we are not going to support private anymore. So we have completely removed that.
Well, and if it's something in the right of way that anyone can see, I don't know why.
I mean, we did have customers for oil and gas and even railway customers. We still do, but even railway customers are, the railroads are actually public property. So there is nothing to be private about that. Like some of the agencies like Vermont, they use public for even uploading the railway imagery. They didn't have any issues at all, but some of them still do. But it's always a bureaucratical challenge, I guess. So we overcome it as it goes. Yep.
That's true. And I don't know, the thing that I see about the open source is when lots of big data sets are out there, it's amazing what people can come up with once they've got the power of that.
Exactly.
You know, the community's building those walkability maps from this type of inventory. That's been pretty cool.
Like some of the cities or even the DOTs who have approached us, they've always wanted to make it open, but they never had the platform to do that. Like Vermont, they had like 7 years of their imagery. They were like, we want to make everything public. And that was followed by Connecticut, Arizona, Utah, and even Florida. They all shared their imagery openly to our platform. And city of Detroit was one of the major cities who actually did that, even with the LiDAR data set. I think they are eventually planning to even share the LiDAR data set openly as well. But they wanted to share all the imagery first. And when they found our platform, they said, okay, we are going to do this. We'll buy the quality rig like Trimble MX2 device and give the high quality imagery to all the open source community as well. Like for a fun fact, I usually say Detroit has the best 360 imagery. Even I don't think Google has that fresh imagery which Detroit has right now. So they might be the only cities who has the fresh 360 imagery, very high quality imagery compared to any other city.
Yeah, a case of this where the name Mapillary came up was it was someone who was looking at a house we had recently sold, and they were in the UK, and they used your data to look at the neighborhoods, the traffic signs, which, you know, there was all kinds of things that they were able to look at that people have extracted out of your data. So that is pretty cool.
Yeah, during coronavirus times, we get a lot of requests for property appraisal because they can't go to the fields to do the collection and everything. We have been getting more requests for how can they do the collection on their own and get that imagery collected and make it available for the city or for the city assessor and everything. So that has been the common request for the last couple of months, where people want to use the platform for property appraisal.
Well, that's a kind of a joke about it, but that's kind of been a dream of mine. The older I get as a surveyor, the more I like the idea of being able to sit in my lounge chair and survey. Yeah.